Good morning, students. Today we're going to look at the types of interest that you can earn when you save or you invest your money. We've talked in class about interest, and there's a type of interest that you pay when you borrow money, but there's another type of interest that you earn when you invest or you put your money in a savings account. And we're going to look at the two different types of interest and see how they're different and how they're similar. The two types of interest are simple interest and compound interest. Now, simple interest is interest that's calculated one time. They calculate the interest, they add that to your savings, and it's done. Simple interest, it's that simple. Now, compound interest is a bit different. In the compound interest, the interest is added to your account periodically, not just one time. For instance, if it's compounded annually, that means that every year they add interest to my account. So let's say I have money in the bank for 10 years. Then every year for 10 years, they're adding interest to my account. They put that interest back in, and then the next year they add more interest, and then the next year more interest on the money that's in my account. That's why it's called compound, because it compounds as you go along for the different number of years. Now let's look at the formulas for simple interest first. So simple interest is I equals capital P, lowercase r, lowercase t, where P stands for the principal, which is the original amount. So the original amount that I put into my savings account is the P, or the principal. Now R is the rate. It's always going to be a percent that we have to change to a decimal. And then the T is the time in years. I have to make sure that time is in years. If I'm given months, then I have to convert that to years. So I've got to make sure that the time is always given to me in years. Now let's look at a situation. With interest, with simple interest, I just take my principal, my rate converted to a decimal, and the time, and I just multiply them together. So let's look at an example. I'm going to erase this, but you can just write under it. You don't need to erase. So let's say that I have $2,000 that I put into an account. Okay? The bank tells me it's going to give me an interest rate that is 2.5%. And I want to leave it in there for 4 years that I'm in high school. So I'm going to put it in at the beginning of 9th grade, and I'm going to take it out when I graduate, and let's see how much money I'm going to have in that account, or how much interest, because this calculation only gives me the amount of interest. So I take 2,000, I multiply it by 2.5% converted to a decimal. Remember that to change a percent to a decimal, we move the decimal 2 places to the left. So this is going to be 0.025 times 4. And then I get my trusty calculator, and I plug it into my calculator. 2,000 times 0.025 times 4, and that is $200. So that equals $200. So that's just the interest that I'm going to earn over those 4 years. So now I can add that total $200 to my original amount, 2,000. So at the end of 4 years of high school, I'm going to have $2,200. Now that's not too bad for putting money away and then doing nothing to it. But let's look at that same scenario. Well, first of all, let's talk about compound interest, and let's see how it's different. With compound interest, I have exactly the same I, P, R, and T, okay? But I use them a bit differently. The formula is different. The formula for compound interest is principal times, in parentheses, 1 plus R raised to the T power. Okay? Now, when we did simple interest, I equals PRT, I was finding interest. When I look for compound interest, I'm going to find how much total is in my account, and then I have to subtract the original amount to find the interest. So let's look at the same scenario. I have $2,000 that I put in the bank. One is always one. It's always one. We never change that. It's always going to be one. Plus 0.025, because that's my interest rate, raised to the fourth power. So let's plug that into the calculator. So I would just type in 2,000, open parentheses, 1 plus 0.025, close parentheses, raised to the power of 4. And it's going to look something like that in your calculator. And then I hit enter, and I'm given $2,207.63. Okay? So in order to find out just the amount of interest I want, I'm going to have to subtract my original $2,000. And I get $207.63. So after the same amount of 4 years, I am earning $7.63 more when I'm compounding interest than when I just do simple interest. Again, the reason for that, and you think, well, that's not very much. You're right, that's not very much. But when we talk about bigger amounts of money in businesses who put money in savings account or invest money, the more money, the longer you have it in. Compounding is always going to give you more money because they add interest more often. Simple only adds interest one time. Compounding interest adds interest every year for ever how many years that you have the money saved. So here's another example. Let's say that by some wonderful occasion, somebody gave me $10,000 to put in a savings account or to invest in some type of account that drew interest. Well, I could put that savings, that $10,000 in the account, and I'm going to find a bank that really gives me more interest than just that 2.5%. Let's say that I double that and I get 5% interest, and I'm going to leave it in there for 10 years. Let's see how much money I'm going to have at the end, or how much I earn. Okay? So for simple interest, I do I equals PRT. So that equals 10,000 times, change 5% to a decimal, move it 2 places, 0.05 times 10. And I'm going to use my trusty calculator. 10,000 times 0.05 times 10. And that gives me $5,000. So that's how much interest I earned over that 10-year period. I'm going to do that one more time because that doesn't sound right. Times 0.05 times 10. And it is. So I earned $5,000 interest over 10 years. Now let's compound the interest and see what happens. So I'm going to take that $10,000 and plug it into my formula. 1 plus 0.05 raised to the 10th power. So after 10 years, how much is going to be in my account? So I'm going to do 10,000, open parentheses, 1 plus 0.05, close parentheses, raised to the 10th power. And again, that's what it looks like. And I hit enter. And my total in my account is $16,288.95. Notice that when it gives me this crazy number. But we're dealing with money here, and when we deal with money, we always have to round to the nearest penny. And we know that the penny is in the hundredths place, so I had to round that 4 to a 5 so that I would round it correctly. So we have $16,288.95. Well, I'm going to subtract the original amount that I deposited, and I'm going to get $6,288.95. And now look at the difference. With simple interest, I only earned $5,000 interest. With compound interest, I earned $6,288.95. That, my friends, is a huge difference. Compounding interest always gives you more interest because again, it adds interest more often than simple interest. Simple interest adds it once, compounding interest adds it more often depending on how many years you have your savings invested. For your practice problem tonight, what I'd like for you to do is calculate the simple interest and the compound interest for this scenario. I have $5,200 at 4.5% interest for 20 years. So I'm going to deposit that money and keep it in the bank for 20 years. That may be something like your grandparents do and then they give it to you when you graduate college. Or you could possibly do that later on for your grandkids. So how much how much interest are you going to earn at the end of 20 years for simple interest? And how much interest are you going to earn at the end of 20 years if it's compounded interest? Do that practice problem, take a picture, and submit it through Edmodo.